Hey everybody, this is Peter from peterstestprep.com. Today we're going to be looking at sequences, part 2. This is the advanced material. This is stuff that you should know if you want to score in the high 20s or 30 or above 30 on the math section of the ACT. In the description below the video, there's a link to a worksheet that you should print out, and you should follow along with this worksheet and follow along with the video, and make sure that you stop the video whenever I say so and do the problems that will be indicated that you should do. This is the best way to learn this material. If you're ready, let's begin. Here's page 1 of sequences, part 2. This is advanced sequences. We'll start with section 4 as I zoom in here, and we're just picking up where we left off from part 1. So repeating sequences. Imagine a repeating sequence as follows: ABC, 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 and so forth. Each term in the sequence has a term number, which identifies its place in line. So we have the term numbers written here underneath the sequence. The first term is A, the second term is B, and so forth. All right, here's the issue with the repeating sequence. We want to try to predict a distant term. So, for example, can we use the repeating pattern to find the 100th term? And of course, the answer is yes. To predict the nth term of a repeating sequence, divide n, that is the term number that you're seeking, by the number of terms that make up the repeating cycle and determine the remainder. Again, you take n, the nth term, or let's put it another way, the term number you are seeking. I'll probably write that in there. And you divide it by the number of terms in the repeating cycle. Our n, the nth term that we're seeking, is the 100th term, and we're dividing by 3 because it's ABC, ABC, the number of terms in the repeating cycle. And we're not just going to divide it. What we're really looking for is the remainder. So this isn't technically correct. Hopefully you know what a remainder is. My experience is that a lot of students who are in their late teens have forgotten what a remainder is because you really haven't done this since the 3rd grade. The remainder is the amount left over after you divide. For example, if I divide 20 by 6, we know that 6 goes into 20 a total of 3 times. 6 times 3 is 18, and there's 2 left over, so the remainder is 2. So the remainder is not the number you get when you divide two numbers on your calculator. It's figuring out how many times does the number go into the larger number and then figuring out the remainder. All right, let's find our remainder. In our problem, we are looking to find the 100th term. That's the term we're seeking. So n is 100, and we're going to divide by 3 because the number of terms in the repeating cycle, ABC, ABC, is 3. 100 divided by 3 is 33 point, and then there's a whole bunch of stuff after that. The important thing is this: the stuff after the decimal is not relevant. The number in front of the decimal is the important number. That's how many times 3 goes into 100 evenly. So what we do is we take the divisor 3 and multiply it by the number in front of the decimal 33 to get 99. The difference between 100 and 99 is 1. And so whichever term in our cycle has the number 1 in front of it, that's going to be our 100th term. That's the remainder 1. So A, B, C, we had 1, 2, 3. So A, you can see, is the first term. So since in our sequence A equals 1, A will be the 100th term. Let's have you guys try that. We're going to have you try all the 4 problems on the right side. It's important to do all 4 of these because they are increasingly difficult. There are challenging problems on this test that when you recognize them, we can realize that they're just repeating sequence problems. So stop the video, do 4A, 4B, 4C, 4D. You'll see a blue screen that will tell you to do these 4 problems. And then when you're done, resume the video. Let's start with 4A as we review these. For the following repeating sequence, predict the 201st term. So that's our n. We're looking for the 201st term. Now we have to determine how many terms there are in the repeating cycle. Well, it's A, B, C, D, E, F, A, B, C, D, E, F. So we have 6. And they're numbered 1, 2, 3, 4, 5, 6, like so. Our remainder is found by dividing n, which is 201, by the number of terms in the cycle, which is 6. And we get 33 point and whatever comes after that does not matter. The divisor 6 times 33 is 198. The difference between 201, which is the term we're looking for, and 198 is 3. And so that means that C will be the 201st term because 1, 2, 3, C is the third term in the cycle. Let's go to 4B. It's an easy problem if you recognize it for a repeating sequence problem. There are 7 days in the week and they repeat. What day will it be 145 days from now if today is Sunday? Well, our cycle, what's the first day in our cycle? It's got to be Monday because Monday is the first day from now. Tuesday is 2 days from now. And I'm just going to write down the whole cycle here. So Monday through Sunday, and then it repeats. All right, well, it's easy from here. Our n is 145. There's 7 numbers in our repeating cycle. When we divide that on the calculator, we get 20 point something. All that matters is the number in front of the decimal. Multiply 7 by 20, we get 140. Out of 145, 140, well, that leaves a remainder of 5 when you subtract them. And you can see the 5th day of the week is Friday. And so Friday is our 145th term. For C, the fraction 2/7 is equal to the repeating cycle of digits 0.285714, 285714. They repeat. 1, 2, 3, 4, 5, 6. I really like to write down the term numbers next to my terms or underneath them, really like so. Right, this way you can see your term numbers. It's easier to visualize them that way, and then they repeat. All right, we're looking for the 60th digit that will appear in the decimal. So n is 60, and there's 6 terms in my repeating cycle. I divide them, I get 10. Point, and what comes after the decimal doesn't matter. Now, you guys will probably know that 6 and 10 multiplied gives you 60. You know that 6 goes into 60 evenly, so we have a different problem here. Our remainder is 0. So now what do we do? If the remainder is 0, then the last term in the sequence will be your answer. This makes sense if we think about it, because if we have a number that we divide by 6, we can get a remainder of 5, but we can't get a remainder of 6. You don't get a remainder of 6 when you divide by 6 because, well, it just doesn't work that way, the numbers, right? It goes into it evenly. You have a remainder of 0. All right, these get harder. 4D, pretty tricky. Find the units digit or the ones digit of 3 to the 17th. Quick review, what do we mean by units digit or ones digit? We've got to travel back to about first grade. I have a random number I've just written here, 325.71. The 5 represents the units or the ones digit. It's its name, its place in the number. 2, that's the tens, 3 is the hundreds. The first digit after the decimal, the 7 here is the tenths, and the 1 is the hundredths, of course. Find the units digit or ones digit of 3 to the 17th. How are you even supposed to recognize this for what it is? Well, that's what makes this a really hard problem. You sometimes just have to start listing numbers down and hope that the sun parts the clouds and understanding dawns on you and you see what's going on here. So I'm going to start 3 to the first is 3. 3 squared is 9. 3 to the third is 27. 3 to the fourth is 81. 3 to the fifth is 243. And at this point, you might recognize, oh, wait a second. I'm only looking at the units digits. 3, 9, 7, 1. 3 to the fifth is 243. When you do 3 to the sixth, the units digit is 9. When you do 3 to the seventh, the units digit is 7. 3 to the eighth, the units digit is 1. So we end up recognizing perhaps that we have a repeating sequence of the units digits. 3, 9, 7, 1. And they repeat, right? Those are your 4 terms. I'm just going to, again, write down the term numbers, which I like to do. All right, now we know what we're looking for. We're looking for the 17th term because it's 3 to the 17th. And there's 4 digits or 4 terms in the recycling sequence. So 17, that's our n divided by the number of terms in the recycled or repeating cycle, I should say. 17 over 4 gives me 4 point something, and we know that the remainder is going to be 1 here. 4 times 4 equals 16. So the remainder is 1, which means that when you do 3 to the 17th, the units digit is 3. That is a hard problem. Let's go to page 2, and the next topic is specialty sequences. We're going to be looking at explicit and recursive formulas. The terminology, we need to get that under control first. So the terminology for all specialty sequences is basically the same. N is the term number. We've already talked about that. Now, A sub n represents the value of the nth term. You might also see S sub n on the ACT. We got to think this through, make sure we really understand this. So for example, consider the sequence, and then we have these numbers given here. So I'm going to put the term numbers underneath them like so. Like I said, I really like to put those term numbers under there. I think that's always a good idea. So if we're referring to the fourth term, we would say that n equals 4. And when we ask for the value of a sub 4, we're asking for the value of the fourth term. Well, that's 13, so a sub 4 is 13. Looking in the box here, well, if a sub n is a given term, a sub n plus 1 gives you the value of the term after the nth term, and a sub n minus 1 is the value of the term before the nth term. If you're just seeing this for the first time, it might make your head spin a little bit. So the key to these, I think, most of the time is determine what your working n is first. Determine n. Determine the term number that you're working with first. Let's see how this goes in practice. We have this problem here under the box. It says, for the sequence above, if we are considering the fifth term, then what are the consequences of that? Well, that means then the fifth term means n equals 5. And a sub 5, which is the value of the fifth term, is 16. A sub n plus 1 means the term after the fifth term, because our n is 5. So a sub n plus 1 is a sub 6, and that's the next term, which is 24, because our fifth term was 16. And a sub n minus 1 would be the term before the fifth term, or a sub 4, which is 13. Just to make sure you understand this, pause the video. Please do 5a. Consider the sequence below. If a sub n is a sub 5, what is the value of a sub n plus 2? So if a sub n equals a sub 5, that's the fifth term. The value of the fifth term is 19. Again, not a bad idea to write your term numbers underneath it. A sub n plus 2 is the second term after the one that we've been working with. So if n is 5, that means then a sub n plus 2 is a sub 7, and the seventh term is 25. Let's go up now to section 6, and let's look in detail at the types of specialty sequences. We have first explicit sequences or explicit formulas for sequences. In these types of formulas, you use the term number to determine the value of the term. So if you're looking for the fifth term, you use the 5 and put that into the formula to find what the value of the fifth term is. For example, a sub n equals 3n minus 1. To find the first term, replace n with 1. To find the second term, let n equals 2, and so forth. So to find the first term, that means n equals 1. What is n? And we plug n, or replace n with 1. So a sub 1 equals 3 times 1 minus 1 is 2. Notice we've used the n value 1 to find the value of a sub 1. When n is 2, we can find the second term. A sub 2 equals 3 times 2 minus 1 equals 5. The second type of specialty sequence is the recursive formula. Here you use the value of a term to find another term, usually the next term. you use the value of a term to find the next term. Example, a sub n equals a sub n minus 1 plus 2. The key to these is to recognize the relationship between a sub n and a sub n minus 1. A sub n minus 1 is a term, a sub n is the next term. With recursive formulas, your term that you're working with is this one here, a sub n minus 1, and you use that to find the next one. So for example, a sub 2 would be equal to a sub 1 plus 2. Generally speaking, you take your term value and you plug it in here for a sub n minus 1, and you calculate out the right side, and you find the next term in the sequence. In order to be able to work with a recursive formula, you need to know one of the values of the sequence, and they'll always give one to you. So for example, we may be told in this particular recursive sequence that a2, the second term, is 4. How do we find a3? You plug 4 in for a sub n minus 1. So let's work through that. A sub 2 is 4. That means the second term is going to be 4. Now that's going to be our n minus 1. To find a sub n, which is a3, we plug in a2 in for n minus 1. So again, notice the relationship between a sub 3 and a sub 2 here. That's the relationship that we have here, the a sub n and the a sub n minus 1. We use the value of the second term to find the value of the third term. All right, a sub 3 then is equal to a sub 2, which we know is 4 plus 2, and that's 6. So a sub 3 is 6. And we would plug a sub 3 in here to get a sub 4. So a sub 4 equals a sub 3 plus 2. So that's equal to 6 plus 2. So a sub 4 equals 8. We're going to have you stop the video and do the next 4 problems, 6A through 6D. 6D you might find very challenging. Give it your best shot and we'll go over it. So stop the video, 6A through 6D. (6A) for the following explicit formula, find the value of the fifth term. Well, that means n equals 5. So a sub 5 equals 3 times 5 plus 2 is 17. We've used the n value, the value of the term number, the fifth term, n is 5. We've used the 5 to find the value of the fifth term. In 6b, for the following explicit formula, find the value of n if a sub n is 45. What does this mean, a sub n is 45? It means there's a certain term number in the sequence, the number 45, but we don't know what the term number is. So we need to find the term number. Well, a sub n is 45, so just substitute in for a sub n, and that equals 7n minus 4, and we get n equals 7 when you solve that. So the seventh term is 45. Moving on to page 3, and we're going to do 6C now. For the following recursive formula, if a4 equals 3, find the value of a7. So the term value that we know, the one we know, goes in here. The one we know goes in there. So n minus 1, that's going to be our term that we're working with. So 2 times a sub 4 plus 3 is going to give us a sub 5. Right? Again, the number they give you is the one that you usually will plug in to the formula to get the next term. All right, here we go. So a sub 5 is equal to 2 times a sub 4, which is 3, plus 3 is 9. So the fifth term is 9. We're going to plug the 9 now in here, the fifth term, to get the sixth term. So a sub 6 equals 2 times a sub 5 plus 3, or 2 times 9 plus 3 to get 21. And then to find the seventh term, which is our ultimate goal, that's equal to 2 times a 6 plus 3. So 2 times 21 plus 3 gives us 45. Now 60 is a little bit harder because it combines everything that we've been talking about here. So as it says, sometimes we'll see a formula for a sequence in which the formula includes elements of both recursive and explicit formulas. For the following recursive formula, if a sub 2 equals 10, find a sub 3. So again, we're starting with a sub 2, so that's the number we plug in there. So a sub 3 is equal to a sub 2. Here's the tricky part. We're looking for a sub 3, so n is actually equal to 3 here. That matches the a sub n, right? N is 3, n minus 1 is 2. So a sub 3 equals a sub 2 plus 5 times n, which is 3. Now our a sub 2 is 10. And so when we plug that in, our term, the third term, is 10. So we're looking for the third term. It says find a sub 3, so our n is 3. Let's go to part C. Special arithmetic sequence formula. You'll have seen this if you took Algebra 2 and they taught sequences to you. In the formula for finding the nth term of an arithmetic sequence, well, it says here, in addition to a sub n and n, the official formula to find the nth term of an arithmetic sequence includes the variable d, the difference. So in an arithmetic sequence, of course, you know that d represents the amount that you add to each term to get the next term. And the formula, a sub n equals a sub 1 plus n minus 1 times d. They give you this formula if you need to use it. They don't expect you to have this memorized. But as we saw earlier, in part 1 of sequences, you can predict what the term number or term value will be down the line of an arithmetic sequence just by using simple logic. But let's just, for the record, take a look at how to use this formula. Take a look at 6e, try it, stop the video, and come back. Looking at 6e, for the arithmetic sequence below whose first term is minus 5, find the 100th term. So a sub n is a sub 100. A sub 1, that's the first term. That's minus 5 plus. Now n is 100. We're looking for the 100th term. So 100 minus 1 is 99. And the difference we figure out just by looking at this. And you can see you're adding 3 to each term to get the following one. So there's your setup. And the 100th term is 292. I've not seen them ask any questions yet about finding the nth term of a geometric sequence. But why don't we just give this to you so you have it. The nth term of a geometric sequence, you start with the first term of the sequence, you multiply that by the ratio r, that's the number you multiply by to find each successive term, and that's going to be put to the power of n minus 1. So again, they'll give that to you most likely if you need to use it. As long as we know what all these terms represent, you can always fill them in very, very easily. It's gotten dark and spooky here, but we're done with sequences part 2. And keep an eye out for your other videos. Make sure you keep these worksheets, study them. The more you know them, the higher your score will be. And if you're looking to get into the 30s, you've got to know all of these worksheets and everything and all of these problems down cold. All right, we'll see you next time. Thank you for watching.